Welcome to my channel. Today marks the beginning of an exciting journey as I start a brand new series on electronics components. In this series, we'll explore how different components work, their types, and their real-world applications. Whether you're a beginner or someone looking to refresh your knowledge, these videos will help you understand the basics and beyond. Let's kick things off with our very first topic, resistors, one of the most fundamental components in electronics. So, let's dive right in. What is a resistor? A resistor is an essential electronic component that limits or regulates the flow of electric current in a circuit. Think of it as a traffic signal for electricity. It helps control the amount of current that flows through different parts of a circuit, protecting sensitive components like LEDs and microchips from damage caused by excess current. Resistors are used in almost every electronic device you can think of, like from mobile phones to refrigerators. Symbol and units. In a circuit diagram, a resistor is represented by a zigzag line or a rectangular box, depending on the standard used. The unit of resistance is the ohm, symbolized by the Greek letter omega, O. The value of a resistor determines how much it resists the current flow. Higher resistance means less current flows through it, and lower resistance allows more current to pass. Types of resistors. Resistors come in various types based on their application and construction. The most common ones are 1. Fixed resistors. These have a constant resistance value and are the most widely used. 2. Variable resistors, also known as potentiometers or rheostats. Their resistance can be adjusted. 3. Thermistors. Their resistance changes with temperature, making them useful for temperature sensing applications. 4. LDRs or light-dependent resistors. Their resistance decreases when exposed to light, often used in light-sensing circuits. How resistors work. But how does a resistor actually work? Resistors are made of materials that do not allow current to flow freely, such as carbon or metal oxides. When electricity tries to pass through, the resistor resists the flow, converting some of the electrical energy into heat. This helps in regulating the circuit's performance and ensures the safety of other components. Applications of resistors. Resistors play a crucial role in various applications. 1. Current limiting. They prevent LEDs or other components from burning out by limiting the current. 2. Voltage division. Resistors are used in voltage divider circuits to create specific voltage levels. 3. Signal control. In audio devices, resistors help control volume. 4. Temperature and light sensors. Thermistors and LDRs, as we discussed, are specialized resistors used in sensors. In short, resistors are the backbone of any electronic circuit, ensuring everything functions smoothly and safely. How to identify resistor values, the color code. You might have noticed that most resistors have colored bands. These bands represent the resistor's value, using a standard color code. Each color corresponds to a number. For example, black is 0, brown is 1, and so on. The first 2 or 3 bands represent the significant digits, while the next band indicates the multiplier. There's also a tolerance band that tells you how accurate the resistor value is. We'll cover the color code in detail in a future video, so stay tuned. Conclusion. So, that's a quick look at resistors, what they are, how they work, and why they are so important in electronics. Understanding resistors is the first step toward mastering circuit design, and we'll build on this knowledge in upcoming videos. If you found this video helpful, make sure to give it a thumbs up and subscribe to Technical Shubham for more exciting content on electronics. Let me know in the comments which component you'd like us to explore next. Until then, keep learning and keep creating.